When we think of poisons, we often think of famous names such as cyanide, arsenic, or strychnine. However, they are not the most poisonous substances known. Join me now as we venture into the shadowy corners of the natural world and beyond, to uncover the truly terrifying power of these silent killers. From the depths of the ocean to the laboratories of man, we'll explore the origins, the effects, and the chilling stories behind these deadly substances. Our journey into the world of poisons begins with botulinum toxin, a deadly substance produced by the bacterium Clostridium botulinum. This microscopic organism is responsible for creating one of the most dangerous toxins known to humanity. It is the most toxic substance known to science, far surpassing any other natural or synthetic poison. Botulinum toxin's lethality lies in its ability to paralyze muscles, including those responsible for breathing. This paralysis can lead to respiratory failure, making it incredibly deadly. Just 1 nanogram per kilogram of body weight is enough to cause death. This minuscule amount highlights the extreme potency of the toxin. This incredible potency has earned it a rather dubious distinction, a potential weapon of mass destruction. Its use in bioterrorism is a constant concern for security agencies worldwide. But botulinum toxin also has its uses in medicine, treating muscle spasms, chronic migraines, and even smoothing wrinkles through Botox treatments. Even the deadliest poisons can have surprising applications in the right hands. In controlled doses, this toxin can bring relief and improve quality of life for many patients. Our next stop takes us to the ocean, where another silent killer lurks. A marine dinoflagellate called Gambiodiscus toxicus produces mitotoxin, the most dangerous toxin found in any marine animal. By increasing the flow of calcium ions into heart cells, mitotoxin sends its victims into cardiac arrest. The true danger lies in its ability to accumulate in the food chain, making seafood potentially lethal. A sobering reminder of the hidden dangers within the ocean depths. From the ocean depths, we journey to the rainforests of South America, home to the poisoned dart frog. These vibrant amphibians harbor batrachotoxin in their skin. By disrupting sodium ion flow in nerve and muscle cells, batrachotoxin leads to paralysis and death. Indigenous tribes use it to coat their blowgun darts for hunting. The frog's vibrant colors warn predators of its deadly secret. Our exploration now takes us to human-made poisons, like VX, a nerve agent classified as a weapon of mass destruction. This deadly chemical is one of the most toxic substances ever created by humans. Developed in the 1950s, VX disrupts nerve impulses, effectively shutting down the body's communication system. It was initially researched for potential military applications. Exposure to even minute quantities can be fatal, leading to respiratory failure and death within minutes. The risk it poses to human life is immense. VX's existence highlights the destructive potential of chemical weapons. Its sheer potency makes it a terrifying tool of warfare and terror. Its use in high-profile assassinations like the murder of Kim Jong-nam shows its chilling ease of deployment and the sinister intentions behind its use. The horrors of VX are not confined to the battlefield. Civilian populations are also at risk, making its control even more crucial. It serves as a stark reminder of the importance of chemical weapon control. International treaties and strict regulations are essential to prevent such deadly substances from causing widespread harm. Our next poison takes us to the castor bean, which contains ricin, a glycoprotein so deadly that a few grains can kill an adult. Ricin disrupts cells' ability to produce essential proteins, leading to organ failure and death. While castor oil has beneficial uses, the concentrated ricin within its seeds is lethal. It has been used in assassinations like the 1978 umbrella murder of Bulgarian dissident Georgi Markov. Ricin remains a potential tool for bioterrorism. The case of ricin highlights the duality of nature. Our journey takes us back to the ocean, to the pufferfish, which harbors tetrodotoxin. This neurotoxin blocks nerve signals, leading to paralysis and death within minutes to hours. There is no known antidote, Despite the danger, pufferfish or fugu is a delicacy in Japan prepared by specially trained chefs. Even the slightest mistake can be fatal. The allure of the forbidden and the fascination with the deadly persist. We now encounter polonium-210, a silent killer discovered by Marie Curie in 1898. Polonium-210's lethality stems from its intense radioactivity. Ingested or inhaled, it wreaks havoc on the body's internal organs. Less than a speck of dust can cause a slow and agonizing death. The 2006 assassination of Alexander Litvinenko highlighted its insidious nature. Polonium-210 serves as a chilling reminder of the invisible dangers of radiation. Our journey now takes us to the shadowy world of 19th century murder mysteries, where intrigue and danger lurked around every corner. Strychnine, derived from the seeds of the Strychnos vomica tree, was the poison of choice for many Victorian-era murderers. This potent toxin was easily accessible and highly effective. It attacks the nervous system, causing severe muscle spasms and ultimately leading to death by asphyxiation. The victim's body would convulse uncontrollably. The victim, fully conscious, suffers a gruesome end, aware of their impending doom, but powerless to stop it. Strychnine's use in murder mysteries cemented its place in popular culture, becoming synonymous with sinister plots and dark tales. Despite its notoriety, it continues to be used today in small doses as a stimulant and in rat poisons. Its dual nature as both a killer and a tool is fascinating. Its deadly legacy continues to haunt us, a reminder of the thin line between life and death and the dark history of human ingenuity. Our exploration now takes us to mercury, a substance as familiar as it is dangerous. Mercury bioaccumulates, building up in organisms over time. In aquatic environments, it is converted into methylmercury by bacteria. Methylmercury accumulates in fish, posing a serious health risk to humans. Exposure can cause neurological damage and developmental problems in children. The story of mercury serves as a cautionary tale about the unintended consequences of human activities. We return to the microscopic world to revisit the deadly botulinum toxin. This potent neurotoxin blocks nerve signals, effectively paralyzing muscles. Even a minuscule dose can cause botulism, a severe and life-threatening condition. The bacteria that produce it are commonly found in soil and water worldwide. The threat of botulinum poisoning is a stark reminder of the critical importance of food safety. Our journey takes us to arsenic, the king of poisons. This odorless, tasteless metalloid has a long history of use in murders and suicides. Arsenic disrupts cellular processes, leading to organ failure and death. Symptoms can be slow and insidious, making it difficult to detect. Even today, arsenic poisoning remains a problem in parts of the world with contaminated groundwater. The story of arsenic serves as a chilling reminder of the dark side of human nature. Our exploration now takes us to cyanide, synonymous with instant death. Cyanide blocks cellular respiration, starving the body of oxygen. Death by cyanide poisoning is swift and agonizing. It has been used in gas chambers, mining operations, and terrorist attacks. The very mention of cyanide conjures up images of danger and death. It is a stark reminder of the fragility of life. Our journey now takes us to brodifacoum, a potent anticoagulant used in rodenticides. It prevents blood clotting, leading to internal bleeding and death. Symptoms may not appear for several days, making it difficult to diagnose and treat. Pets and wildlife can be poisoned if they ingest bait or prey on poisoned rodents. In humans, even small amounts can cause severe bleeding and death. The case of brodifacoum serves as a reminder of the unintended consequences of poisons. Our final destination takes us to dimethylcadmium, a highly toxic and flammable industrial chemical. It interferes with cellular processes, causing widespread organ damage. Inhalation of even small amounts can lead to severe lung damage. Dimethyl cadmium is also incredibly flammable, igniting spontaneously upon contact with air. The extreme danger posed by dimethyl cadmium highlights the importance of stringent safety protocols. Our journey into the world of poisons has revealed a diverse array of substances capable of causing great harm. Determining the most dangerous depends on factors like lethal dose, effect on the body, and likelihood of exposure. While some poisons are incredibly deadly, they pose little risk to the average person due to limited exposure. By understanding these dangers, we can better appreciate the fragility of life and the importance of responsible handling of hazardous materials.